From a distance, a massive construction site looks chaotic. But watch closely, and you will see a highly organized ecosystem at work, and none of this movement is random. Building at scale requires specific physical actions: digging, pushing, lifting, packing. Because the physics of each task are completely different, construction does not rely on one giant universal machine. It relies on a fleet of highly specialized tools. The baseline of this entire system is the excavator. Engineered to extract earth from deep below ground level, its core features are a rotating upper body and a long articulated boom and arm. This gives it the flexibility to dig a trench, swing the dirt to the side, and reset for the next scoop. For smaller jobs, you need a hybrid approach. The backhoe loader combines two jobs into one mobile, wheel-based frame. It mounts a loading bucket on the front and a smaller digging arm on the rear, making it highly effective for utility work, where moving quickly between spots is essential. Instead of digging deeply downward, the wheel loader is built for rapid surface work. It uses heavy tires and a massive front bucket to scoop bulk materials, like gravel or loose dirt, and ferry them quickly across the site. When space is extremely tight, engineers scale that versatility down. The skid steer loader is a compact multi-tool. By varying the speed of its wheels, it turns sharply within its own footprint, allowing it to navigate narrow urban corridors while swapping attachments to move dirt, lift pallets, or clear debris. But breaking and scooping earth is only the first physical hurdle. Piling up loose dirt does not build a foundation. To actually shape a site, you need to apply massive horizontal force. Preparing the bare ground for construction requires machines optimized entirely around pushing mass horizontally. The primary tool for this is the bulldozer. It generates immense traction through a heavy tracked undercarriage, channeling that grip into a massive front blade. It pushes thick mounds of soil, rubble, and debris out of the way to clear rough terrain. Where the bulldozer applies brute force, the motor grader applies precision. It relies on a long, adjustable blade suspended underneath the middle of its chassis. As the machine drives forward, that central blade shaves the dirt into smooth, level surfaces and exact slopes. Once the ground is leveled, thousands of tons of excess dirt and rock remain. The dump truck solves the logistical problem of removing that mass off-site. It uses a hydraulic open cargo bed that carries heavy loads over standard roads, then tips upward to empty the material instantly. Standard trucks fail in deep mud or harsh quarry environments. For extreme terrain, the articulated dump truck uses a flexible pivot joint in the center of its frame. This keeps all its wheels planted on uneven ground, ensuring heavy loads keep moving far off-road. At this stage, the earth is shaped and the excess mass has been transported away. The site is flat. To start building the actual structure, construction crews have to solve a new engineering challenge: defeating gravity. This diagram shows the shift in forces. Moving heavy steel beams and precast concrete elements requires machines engineered entirely around a vertical lifting vector, prioritizing stable upward pull and pinpoint placement, rather than earth-moving power. The solution is the crane. By using a long structural boom, high-tension cables, and heavy hooks, cranes safely hoist the massive structural objects that other vehicles simply cannot reach or balance. From massive urban high-rises, this geometry scales up into the tower crane. A fixed vertical mast is anchored to the ground, balanced at the top by a long horizontal jib and a massive counterweight system. This allows crews to reach the heights of a city skyline. Down closer to the ground, the telehandler acts as a mobile lifting hybrid. It marries the maneuverable base of a forklift with a crane's telescopic boom, extending forward and upward to deliver pallets of material straight onto second or third-story floors. Lifting machinery gives a building its structural skeleton, but making the site usable requires a completely different class of machines dedicated to laying down permanent infrastructure. In the finishing phases of construction, the goal shifts from moving mass to creating long-term stability. Loose dirt and fresh gravel will shift under pressure. The road roller uses an extremely heavy steel drum to physically compress the soil and asphalt. Packing the material tightly together locks it in place, creating a firm, supportive surface that will hold weight without buckling. Before that surface can be rolled, the asphalt paver has to put the material down. Unlike the roller, the paver does not apply heavy vertical pressure. Its distinct job is to take hot asphalt and spread it in a perfectly controlled, even layer across a prepared roadbed. Laying foundations requires wet concrete, which introduces a strict time limit. The concrete mixer truck solves this by continuously rotating its drum during transport, keeping the active, fast-hardening material agitated and fluid until it arrives at the pour site. For installing essential underground utilities, we see the extreme end of machine specialization. Laying pipes requires perfectly narrow, straight channels. The trencher uses a heavy-duty mechanical chain to slice directly through hard earth, doing one specific job flawlessly. As a site nears completion, broad multi-purpose tools fade out, replaced entirely by these hyper-specific machines designed for exact single functions. Backing up all this heavy equipment is a micro-level support network. Smaller vehicles, like forklifts, handle short-range tasks, shuttling pallets of supplies, tools, and replacement parts across the dirt to keep the giant machines fed and operating. When you step back and view the entire life cycle of a construction project, the necessity of this vast array of specialized machines becomes perfectly clear. This project timeline shows how the ecosystem interlocks from day one. Machines arrive to dig the deep foundations, push the rough earth into shape, haul away the heavy debris, and precisely grade the bare dirt. Then the roles shift. The system moves to lifting the heavy steel, delivering the wet concrete, laying the fresh road, and compacting the surface to a finished seal. We build modern infrastructure at a massive scale because we abandoned the idea of a universal tool. Instead, we rely on a specialized mechanical ecosystem where every machine has a distinct role and every role connects.